All right, let's go ahead and get going. Um, Welcome to the Lamps Working Group at Ietf114. Remind you first of the note well. Please make sure you understand your rights, privileges, and responsibilities according to these. Please don't contribute until you do. Of course, it's my brother. I was afraid of you about this. Um, so please follow the IETF Code of Conduct and, basically treat each other with respect, and that will lead us to the better technical solution. We don't want to lock anyone out of the discussion. And at this particular meeting, in addition, please wear your mask in the session, and only the presenter should be maskless. We have a long agenda, but it turns out some of the things are not going to happen today, so we might actually get through it. We'll see. The first group of documents are the things that are with either the RFC editor or the ISG. And so we'll only be talking about those in terms of what's changed as they've gone through the process. Then in the Pkix related documents, just a day or so ago, Tim declared that we've reached consensus on 3709 BIS. So the only thing we're waiting for that to move to the higher category is the Shepherd write-up. And the next one's the SMIME documents. We have not seen those documents updated since the last IETF. So there's probably not much that we'll be talking about today. In fact, I did not get slides. And then there's the list of documents that, yes, Roman.
No, I just wanted to, so Roman Janello, if you could flip back a slide, I just wanted to say kind of thank you for everyone with the agility we had on the LAMP CMP kind of update. When we went to the ISG, we got some feedback on the editorial style and the length of time in the old kind of new. It was explained kind of how we got there kind of organically as a process. There was still kind of a little bit of a rub. So kind of thank you for kind of the rapid reaction and the commitment to do kind of a full BIS. This was really key to getting us over the finish line. It's, it'll give us something immediately for the community, and then we can work kind of long term on that. So again, kind of big thank you as a team effort across kind of all sorts of things to get this. So much appreciated.
The bulk of that thank you goes to Hendrik. All right, and then there's a whole slew of documents that we're going to consider for adoption, and of course most of them are post-quantum related. There's a couple that are not. My intent is to deal with, in terms of processing them, deal with the not PQC related ones first, get them off the plate, and then the PQC ones, we have a little more runway. We're waiting on NIST and so on, but the order somewhat reflects that, and then some other things came in at the end, so we'll deal with them as they do. Any agenda bashes?
Hey, Russ,
No,
I
go
have
ahead.
something
Go
real
ahead.
quick. This is, Clint Wilson. I know there won't be time to talk about it today, so I'll send this over to the list, but I have a 5019 BIS that I plan on submitting just to kind of update the SHA-1 requirement in that RFC.
Okay. Yeah. So okay, that's news to me, but please send it along, and please post something on the list.
Yep, I'll send it over the list. Absolutely,
Okay.
just
Great.
for consideration for adoption. Thank you.
Okay. Thank you. Any other bashing? All right. So, Sean, I don't see your other authors in the room. Is there anything to say about document signing? EKU.
An updated one of the co-authors.
Oh,
here.
there he is. Sorry.
So we got an update done. We get some minor clarifications that were requested. So we did that. And so
Okay, so I saw the document was posted yesterday. I looked at the diff. I hope others did too, but they were basically all to address comments from Roman, if I remember right.
No, that actually happened a couple days ago. We're in RFC Ed already.
Oh, but that was the last thing, right? Yeah. Okay. The 8410 KU clarifications, is there anything to share with the group? I don't think there's been any changes in this one. Okay. CMP algorithms and updates and lightweight Hendrix set slides, so there must be something to say.
Yeah, hello, thanks for
Getting there.
Can you hear me? Sorry.
Yes, we can hear you. I just need to pull the slides up.
Okay, thanks. Yeah, first of all, thanks for Roman for his mentioning the efforts on pushing the CMP updates through ISG review. Next slide, please.
I had passed slide control to you. Did you not receive it?
Yeah, I see it. Thanks.
Okay.
Okay, CMP algorithms. It passed IESG review and was approved, is now in RFC editors queue. Yeah, so nothing much to say. Thanks to Roman and Russ for supporting the document. Next slide, CMP updates. So there was some discussion in IESG. So the end of May, IESG didn't approve it, and there was mainly discussion on the style of the document next to a number of minor editorial stuff. And yeah, as Roman already said, IESG requested that we provide a 4210 bis document. And yeah, if we do that, I would also propose to provide a 6712 bis document, as CMP updates also update this RFC. We discussed this already last IETF, and I will come back to this topic on my last slide. So just since last IETF, we updated, as discussed at IETF 113, the well-known path and the definition of the path segment P for profile or CA names. Good. Lightweight CMP profile. There were some minor updates since last IETF. Also, some clarifications coming from implementations and alignment with CMP updates regarding the well-known path segment, and some editorial stuff, but nothing much to say about it. Yeah, we are waiting for AD review and looking forward to the valuable feedback we'll probably receive. Roman, can you say anything about when you think you will have time to work on this?
Hi, this is Roman. Yeah, that's a fair question. It's the next one in my review queue. It's just been hard getting through the previous documents. So I think if you give me a week or two after the IETF, I'm going to spin it back up.
Yeah. Occasion anyhow. Good.
Got it. So European, so October 1? All right, perfect.
Yeah, actually, we in Bavaria are quite late with our summer vacation. That's right.
That's funny.
Good. Coming to 4210 bis and 6712 bis, as already mentioned, this is on request of IESG. They regarded the style of old text, new text, as CMP Updates was written as, yeah, not well for implementers to read. I fully understand this. So in the beginning, that was a decision we took for this document, as we didn't plan to do a general update of CMP, but only some changes. And to be honest, there are only two real changes. One is on exchanging enveloped encrypted value with envelope data, and the second is to add an explicit hash elk OID in the set conf message. All the other stuff is either fixing errata or adding some new OIDs where already flexibility was foreseen, like for general messages, for example, or defining an extended key usage value. So yeah, now we have the situation that we have to provide these documents. I welcome everyone, especially those who were involved in writing the original RFC, with supporting this activity. From the group of authors of CMP Updates, we can provide a 0.0 version that contains mainly the original RFC text, providing a 0.1 version, providing the changes provided by defined in CMP Updates, and most likely a 0.2 version doing some fixes reported by IDNITs, and maybe switching here and there to more current RFCs in references, or aligning some text where needed. But that is it, what we would plan to provide. But from the feedbacks from IESG members, I understood that there will be some complete review of the documents, the BIS documents, and therefore I would expect that there will be some further discussion going on, and I feel like we need help of the original authors to get that input on those design decisions back 2005 in the discussions, because we do not want to define a new certificate management protocol, but let's say only do some adaptations to CMP where needed for the lightweight profile. At least that was the original aim. Therefore, everyone, especially those authors from the original RFCs, are welcome to join in. I sent out an email to those last week, but didn't get any feedback yet. So any feedback is welcome. Also, if they step back from co-authoring, that's also good. But then I at least know, and yeah, do not miss some feedback. Yeah, so that's it. There are people in the queue. So Mike.
Mike Ounsworth. I'm a co-author on this. I really want to highlight what Hendrik just said. I mean, opening this up to Abyss, I think, is going to open up questions like, why not TLS? Why not HPKE? And within the authors group, we have some historical knowledge here, but probably not enough to field all of that. So help from the working group to deal with whatever comes out of review, please.
So I completely agree that this is a document the protocol effort, not a redesign the protocol effort. Further, this document being from 2005 is what we call pre-5378. The IPR regime has changed, and 5378 is the watershed event where that IPR changed. So we do need permission from all the authors to get their rights. So the original authors, yes. And so even if they don't want to contribute to this effort, they need to give us the rights to continue. And so I hope that does not become the roadblock. Roman?
So hi, Roman Dinity, Responsible AD. So I want to pick up on two things that might help us with the glide slope here, and one of them is directly related to how big of a box we're going to open here. So procedurally, this is actually going to be an interesting situation I haven't encountered before, because what often happens outside the SEC area when you open up the protocol, security is always very concerned. Will you make me update and upgrade all the security kind of properties? And there's a bit of a negotiation that sometimes happens as to why this document is produced, what the intent is really to BIS, and whether we're going to reopen the can of worms on the security considerations. So one of the things that would kind of help me as we talk about it in the working group is, let's kind of iron out. I mean, we know why we're making this update. This is a push from the ISG. Let's talk about the places where that might be hot spots that there might be discussions to update, but we don't want to. And I can have a conversation with the ISG about how to handle that. I mean, this sometimes kind of occurs, typically not in SEC documents. So asked here is, am I talking about security considerations? It could in non-SEC protocols, it typically is the security considerations and kind of the assumptions made. Here, we were probably talking about fundamental parts of the protocol. So we may need a reason about that. And then the other one, the other kind of thing to know, which I think is just much easier. I mean, Henrik put in kind of some good work in documenting the implementations, which also helped with the glide slope for approval here. So I would kind of urge to document that really well as we bring this document forward, to really show that we're putting in IETF documents the state of play, and that also kind of helps with how wide of a box we have when we reopen it.
So Roman, are you suggesting an advance in the proposed to full?
You mean putting that as table stakes, what's changed, what's not in advance?
Well, no, I mean, one of the things we often do is document what implementations exist and so on.
Right.
We know we have more than 2 interoperable implementations, so we could just try to put the BIS documents to full standard.
Yeah, we could. I guess I don't have an answer on that like right now.
Okay.
At the mic, yeah, we should kind of figure out. I mean, if that's what we want to do, I mean, I'd see no reason. I was thinking something less ambitious, really just document it really well in the Shepherd report as kind of justification for the design choices. But if we want to go a little further, I mean, and we clearly have the implementations, we certainly could.
We do. Okay. We'll have that discussion. We'll have that discussion at some other point, I guess. But
It's been pointed out we have no note taker.
oh my goodness. Sorry,
Yeah,
I
so
was so worried that this was. Okay, can we get a couple people to open up the notes link and help us out? Please, thank you. 2 people would be awesome.
I think Deb said she's
Oh.
also helping.
Thank you. Thank you so much, and appreciate it.
So there was a question on the IPR thing.
Go ahead.
I guess, Russ, please correct me. We fixed this with contacting the original authors, and they all provided the right to switch to the current.
That's awesome. Good news.
Yeah, so this should be documented on the list in the mail archive. If needed, I could figure out which emails that was.
No, that's just awesome news. I forgot that we did that for the updates. Contacted them, but thank you. Okay, and I don't see anyone else in the queue. Any other? All right, let's move to the next presentation. Thank you, Henrik.
Thanks.
So the next one is 3709 BIS. Nothing's changed since this document that has just last week had consensus called. So the next one on the agenda is header protection. DKG or Alexi here are both here. Anything to share?
Hi, this is Daniel Gilmore. No, it's been a little bit stalled, which is on me. We have, I think, reached agreement about the way to handle that. There was one piece of subtlety that came up at the last meeting that we discussed around for header protection, around how the recipient should know what happened when the header confidentiality policy was applied. And I think we reached an agreement on what should happen there, and I have failed to write it down and produce the samples. So I'm still working on that.
Okay.
So sorry for the delay.
So is that something that we're likely to resolve by the next IETF?
Yes.
Awesome, because I really was hoping to clear this before we dig into the PQC stuff.
Yep.
Right.
It is something that I'm aiming to get done before then.
Okay. Don't sit down yet.
Okay. This is my public,
Same
public
question
embarrassment.
for end-to-end mail guidance.
Yeah, the end-to-end mail guidance, I have not gotten a lot of feedback from, which is a little bit distressing to me because I know that there are people in this room and people who are remote and people who are on the mailing list who have experience to share. And we have not gotten a lot of additional suggestions. The document has fix me's. If you don't want to say, hey, I've got an idea I want to add, but you want to just pitch in and say, I think I know how to solve this particular problem, I would welcome that. I am trying to record the things that I've uncovered in terms of like the kinds of paper cuts that people actually have. And I would love to have more contributors on that. I know that it is expired right now, and I will refresh it and I will fill in some of the fix me's, but I really hope that some of the other expertise in the room will contribute their hard-earned lessons for everybody else. So again, I'm behind on this, but I really would appreciate more people stepping up with suggestions.
Okay, so this is Russ. I promised to read it and join in the discussion. Are there any other SMIME implementers willing to make the same commitment? Good, thank you. For the notes, that was Alexi. Go ahead, Rich.
Yeah, do you know Alec Muffet?
Rich, point it down.
Pardon?
Where your mouth is.
You might want to reach out to him because Alec is big on end-to-end security stuff. I don't know how much experience he has with SMIME in particular, but. Okay. Okay. I also said that so I could walk to the front and sit down without.
How clever.
Alex Imanakov. I did read the earlier version, and I think I had some minor comments. I think the bigger part is about terminology used, just because it's not fully aligned with email terminology. But I think once it's fixed, it's going to be. So, but yeah, I'll commit to doing a review again, and I'll send you all the comments.
Okay, Michael Richardson, you're next.
Okay, am I close enough to the microphone? Good. All right, I'll come back to the first slide that I, just copied and pasted from last time. It's a terrible title. I would love to better title, something more cool.
More
next,
cool.
pardon me?
More cool.
More cool, yeah, with like bigger, smaller words. I don't know. The story so far. RFC 7030, which is EST, enrollment over secure transport, was a little bit unclear about CSR attributes, which is a thing that actually it created. We over in Anima used it the way that we thought that it worked. And I don't quite remember how we came across the fact that this was probably wrong, maybe because of the CMP work that Henrik is doing.
I think it was Sean.
Pardon me?
I think it was Sean.
It was Sean. Yeah, someone noticed that we did it wrong. And anyway, we had a virtual intro meeting at the end of August 2021. Those some links if you want to go see that. Talk a lot more about what went wrong. And we concluded that we needed to fix it. And there was a bunch of different ways of fixing it, one of which was that our interpretation was correct and the document was wrong. And another one was that the document was right and our interpretation was broken. And that, we went through a couple cycles and we actually concluded the document was vague and wrong and that our interpretation was also wrong. So, the last time in Vienna, Sean said, you know what, we just need this extra layer of extension request. That the document was kind of right, just didn't really clearly say that. So next slide, please. So this is what we were doing. Okay, we were saying, hey, we want this subject alt name, so we'll put that in, and please do something. Okay, and we have running code that does this, and it's wrong. Next slide, please. So this is what it looks like now. This is what we would do. Okay, so we would start off with this extension request, and within that, we put an extension, exactly what we want. It's a 3-item thing with a critical bit in there, the Boolean, subject, an OID, and a value at the end, or a set of values, or a sequence of values there. And that's really it. So all the other uses where you say, I want you to use algorithm 123, here's the OID, those all remain the same. So I think Dan had the question about we didn't want to break what was on the wire already for other people. This is what it looks like right now. I would invite you to, think about that. Next slide, please. That's really it. Yeah, so questions. We think we're ready for the working group to adopt it. We can then fill in some additional examples. So that's one request out there. If you have any running code that does anything at all with 7030, then consider, consing up an example for us and run it through dump ASN1 so that we can really say, to people, when I wrote my code, I went through the 3 examples that were in 7030, and I didn't really understand the ASN1, to be honest, but I knew when I had parsed it right. So that was the key part. It's a complicated bit of code, and I think it's a non-trivial. They use the coolest mechanisms possible. So, Sean.
Hi, Sean Turner. So someone who caused all this problem. Can we adopt this? This seems like a perfectly good draft for the Lamps working group. I don't know that the L in Lamps anymore is true, but this seems like a perfectly good reason. Really the joie de vivre for this working group was to do this kind of thing. So I would support adoption now.
Okay.
Does anyone in the room think we should not adopt this document? Does anyone remotely think we should not adopt this document?
I have a question.
Sure.
Yes.
So a long time ago.
What's your name?
My name is Roy Williams, Microsoft. A long time ago, we had an issue with Japanese subsidiaries putting a stop ship on us for using UTF-8 for their networks because of the large explosion of content that goes on the wire.
Okay.
Do we have any need to use a UTF-8 in this case here?
So we want to go back one slide. I think that's where he's reacting. There's probably just left button. There you go. This is the piece at the bottom here.
Can I answer that more succinctly?
Okay.
This is using a piece of RFC 5280, which uses directory string, which is a choice of which UTF-8 is one of.
Yep. That's what I was going to say. And
Okay.
in RFC 8994, we say you shall do it this way, but in your network, you will do it the way you want.
Okay.
Okay.
I just wanted to make
So
sure.
just my example is in UTF-8, and that's because that's what a different RFC says we're doing it for.
Okay. I just
Okay.
wanted to make sure we weren't going to run into a buzzsaw of issues.
Yeah, you could contribute an example. Thank you, Rich. Yes, exactly. Please contribute an example that's not in UTF-8 so that no one gets confused next time. That would be wonderful. Thank you. Yes? Anyone else? Anyone else?
Okay.
All right,
So,
bye.
we'll do a call for adopt.
Roman did any responsibility. I will also do the pesky task of looking at the in scope of the charter because, as we know with lamps, we have a rigid list of what's in, what's out.
I believe clarifications is in that list. Okay, but. Yeah. But Sean. Not
Hello
for the
again.
remote people.
Yes, the remote people would not hear me, but in here they would. So hey, so this is a new draft that came up. It's basically is John Madison here? I saw him there he is at the back. So he sent an email and said, hey, you know, the 3GPP guys have this way to put network function types in certificates. Kind of think they're not really doing it right. What about what we do? So we basically pumped out a really simple draft to specify a way to do that. And that's really the whole thing. One more slide. And this is my only slide. I want to make sure that we talk about the PQC stuff more. So the motivation really, again, was this email really was what really happened. But the idea is for these network function types for 5G systems, right? So they've got the service-based architecture and these, you know, things on the network are talking, and they've got a certain set of names. And, you know, how do we stick these things in the certificate? And they're all ASCII strings, which is really nice because then we don't have to worry about these ETF explosions, and they can keep it short, which is really nice. So, side note, I will tell you that getting through the ISG saying everything is an ASCII string is a fight. It's going to be hard, and it's just standards like you put it on your back and you carry it. We put justification for why we're using ASCII strings to be able to get us out of this problem. So when our responsible AD is carrying this through, it can be like, they only actually use ASCII strings. And so that's nice of them because it makes it a little easier because it's smaller. And so there's an actual 3GPP spec that actually lists what those things are. They are ASCII. The only thing that's really weird is they have an underscore. So that's why it's IA5 string and not something else. But the basic idea about, hey, where can you put a name? Well, you can put a name in an existing naming attribute. So you have like a subject name in a certificate, country, common name, you could bang it in there. Well, that doesn't really seem like it kind of didn't make much sense. You can find another name in general name. No one's going to support that. So good luck with that, right? So the other idea is define a new extension. Maybe it's a little easier, and that's kind of what we settled on, and we thought, okay, and the extension is that. It's very simple. It is like a sequence of NF types, and we put, we went to go with all the ASN1 options so that we could make sure that we could kind of like put a size and it's not kind of unbounded. And they're restricted to 32 characters in length, and that's really it. And that's kind of it for the draft. And we think that it'd be all right to specify here, because usually in the way the references go, right? 3GPP oftentimes specifies and points to the IETF RFCs. And so we figured we'd do it here, do them a solid, and be done with it. And it's a very simple draft, and that's really it. So pretty much the ask is, hey, did anybody read it? And if you did, what do you think about adopting this?
So the only thing I want to add to what Sean said is the NF types that are defined in the 3GPP spec are all 8 characters or less. We 4x'd it to make sure that we weren't blocking people, but yet not making it unbounded. We thought 4x probably was adequate to deal with that. And of course, since I'm a co-author, Tim will make all consensus calls on this. John.
Yeah, John Mattsson. Some background. So this is already specified in a bad way in 3GPP, which causes problems. It has been identified by Ericsson as a problem. I think it has been discussed in interop tests and so on, but I'm not 100% sure exactly how. I don't think there has been any official formal discussions in 3GPP, no contribution. I don't know if there has been offline discussions there. Yeah, just a summary of this.
So I guess all I want to say is to our ADs, if there ever is actually a fight, they can, if they want it, 3GPP is like, that's a great idea, we're going to do it over here. Great, do that. Like, no one's fighting to like, let's keep it here, no. So we figured this was just an easy, it's like literally a slam dunk kind of internet draft to get to RFC. Not going to take the typical 3 years. Let's, just get it done. So.
I think the next step is probably to get 3DPP input and discussion.
Yeah.
Yeah, I read the draft. More importantly, I read the whole email thread, which I think was longer than the draft.
It is in fact, yes.
And yeah, this seems like an obvious slam dunk, so I fully support adoption, and I'll read the next version of the draft, which is even
Oh,
smaller.
only read the diffs. It'll be shorter than the email.
I don't know. Diff is, maybe not.
Right. And so my only concern when I wrote this actually was, what was the string type going to be? Like, do we have to restrict it? Like, really? And it's funny because, like, if they're like, oh, well, they're going to keep using ASCII strings, great. Well, it makes it a little easier because it keeps the cert smaller, which, as we know, is a thing, right?
All right. So it sounds like a lot of people are in favor of adopting this. Is anybody against adopting this document in the working group, either in the room or remotely? Looks like that's a no, so we'll take it to the list. Thank you.
Carl Wallace, we're going to do your key attestation next.
Can you hear me?
Yes, let me just find your slides.
Okay. So next slide.
I pass control to you.
Me. Okay, good enough. So here's a link to the draft for those who haven't read it, and a link to the editor's copy. I don't think there have been any changes since the 0.0. What we want is to have this accepted as a working group draft and proceed on standards track. Why is it necessary? Keys can be generated in software or hardware for a good while now. A lot of hardware modules have been capable of providing verifiable key attestations. We'd like a way to pass that to the CA so it can either tailor certificate contents or possibly reject requests that lack the characteristics that it desires. So why did we use the WebAuthn attestation statement format? There are a bunch of different formats for key attestations, so this needs to be agile. Work that I've done that's been in use since 2018 used proprietary OIDs for each format. But when we set out to write this, there was already a draft brewing in the Acme group that was using the WebAuthn format. So just to make life easier, we stole a bunch of text. And this question here actually isn't a question anymore. So I'd wondered from the beginning whether or not using the WebAuthn registry was okay. So I talked to Roman yesterday, and he suggested I talk to one of the registry experts. I passed Mike Jones in the hall and asked him, and he said we'll need a new registry. So we can't reuse the WebAuthn registry for attestation statement formats that aren't organic to WebAuthn, which isn't a particularly big deal. So we'll change the draft will change at least for that. Why these various cert request protocols? Because we have a load of them and they all more or less behave the same with respect to this. This value can be passed as an extension or an attribute. And because Acme is already covered by Brandon Week's draft, which will be presented tomorrow at the Acme session. So what do we not cover? We don't cover format specific details. So that'll be left to whatever draft is referenced in the registry. So right now, if you look at the WebAuthn registry, all of the statement formats are defined in the WebAuthn spec. but in the future that might not be the case. So we punt those to the spec formats. I guess that's it. Is any questions?
Thomas, go ahead.
Can you hear me? Hello,
Yep.
hello. Oh, hi, Carl. Incidentally, we picked the same WebAuthn format to wrap different kinds of attestation evidence in our attested TLS extension, and we had the same exact question with regard to how and where one defines new formats. Is that W3C, IANA, someone else? If I understand correctly, what you said, you are going to create the IANA registry in your draft. Is that the case, or I misunderstood?
That's the plan. And Sean, you can chime in with more detail on that if you like.
Okay, another question, sorry, very quickly. Is there any need to coordinate with W3C on that, or is it something that we just do unilaterally?
I don't think so. I mean, we're just using the format as it's defined and defining a place to register this stuff for this purpose. I don't see why that would need coordination, but I have not asked that question of anyone.
Okay.
Anyone else?
Yeah, so to add a little more concrete there, we're just, we have IANA, so we'll use them to run the registry. So we'll just specify what the name of the new registry is and go from there. It'll be pretty straightforward. Sorry to jump in there.
Stefan?
Yeah, I'm trying to unmute, but I think I succeeded. So is the purpose of this to signal the aspects of the private key that is associated with these public key of the certificate, right?
That's right.
So I'm not saying that you shouldn't do this way. I just want to report that there is an overlap with Etsy has since many years ago a mechanism in the qualified certificate statements extension reporting on the aspects of the private key associated with the certificates. It's used mainly to say that this is a qualified signature creation device, but you can register any kind of identifier for whatever type of key protection you have there. So just to make you aware that there is such a function that is widely deployed already.
Well, I mean, the problem is that the WebAuthn format is also widely deployed, and we're not creating this condition. We're just choosing to piggyback off of this that exists.
Yeah. Yeah, I just wanted to point you to the fact that this also exists.
I suspect Brandon will say more about this tomorrow in Acme, so if you're around tomorrow, give a listen to that.
Bonnie?
Yeah, Monty Wiseman, Beyond Identity. I think maybe
point the mic down.
I was trying that. It's a little tight. I don't want to break it. All right. Anyway, Monty Wiseman. Know a little bit about the TPM, and I've seen lots of, for example, TPM implications. Which this would be among the type of items you would apply to this. Looking through it, I think, and maybe the previous speaker's suggestion needs to be looked at. Just a simple binary of hardware versus software, I think, is going to be very difficult for people to ascertain or make a decision on. There's lots of implementations. Is hardware mean a separate IP block inside the chip, a separate chip itself? Anyway, so I think there's going to be lots of variability. People are going to want to set the hardware bit. What sort of criteria do we have for a hardware bit? We've got like things with normal world and secure world, for example. Things over in secure world, is that hardware? It's the same piece of silicon that's actually executing the instructions as the normal world. So I think this is going to be a challenge to simply make it a binary decision. Secondarily, go ahead.
Oh no, I agree with what you're saying, and even within just the Android format, you see a lot of variability there. There's Strongbox, there's TE. I think there's even attestations that indicate software. That as with what I said to Stefan, that exists. We're not creating that condition. We're just providing a means to convey this information to the CA to appraise however it wants to appraise. And I think that's kind of what you're getting at is the appraisal process. Some folks are going to do it different than others, and that seems okay to me.
Well, I think you're going to have a challenge. The appraiser's going to need more information than just a bit to make this determination is what I'm saying. And just having a simple bit, I'm afraid is going to be overused and then become.
Well, there's not a bit. There's a statement format, and that format definition is referenced in the registry. So there's lots of words written about all of these formats, right?
Yeah, I understand that in the attestation statement, you could provide more clarity, but then what's the point of just having this bit? I guess
I'm not sure what bit you're referring to, actually.
There's a binary value right before the attestation statement.
Let me pull that out.
That's the one I'm questioning.
And maybe that's something that we should look at now that I get what you're saying. Can we just take that on the mailing list?
Yeah, I'll post. Okay, yeah, I've got. Have you thought about adding something like this key has certain attributes such as policies associated with using the keys? Would that be out of scope for this particular extension? Maybe it's another
I think
extension.
that's part of the attestation statement format. And to reference Android key attestations again, there's all kinds of stuff like that that appears in an Android key attestation. The usage, the algorithms, that kind of stuff. That's all there.
Okay. All right, I'll dig deeper into that. Thank you.
Hello, Sean again. It's funny actually. We thought about many of these things and was like, okay, well, what's going to work? The funny thing is, can you go back to slides where it's like why and the list of all the various enrollment protocols? Yeah, back one where it's just like why, because there's so many of them, because Pkix could never actually fix one. My biggest worry was that we were going to actually refer to SCEP in a normative format and have to downref it, which would put it on the standards track. So I just want to throw that out there that, for the ADs that are later going to be passing this to the thing, everything else up there seems to be great, but SCEP is the really weird one on the list of things to do. So just kind of remember that. And it's because again, we're just defining this format thing that you could put in any one of these enrollment protocols, and there's 5 or 6 up there, and there'll be more later. So
just make sure it's an informational reference.
Yeah, well, whatever, we'll figure that out. But I just
the issue with SCAP is it's the payload format that's in Apple's over-the-air profile configuration delivery protocol. So that's a whole lot of devices that are doing SCAP.
Yep.
All right, Ietf114. So I think it's worth noting that even though WebAuth attestation is widely available and, in some sense, extremely widely deployed, there is not a huge amount of deployment experience for relying parties actually processing WebAuth attestation and doing anything with it. And in that respect, the stuff that Stefan talked about, the qualified certificate extension, is in a sense a little bit more mature in the sense that it essentially references a big spec of behavioral requirements. That's what qualified certificates do. It's a sort of a federation specification. And whereas the WebAuth format is, a set of values, right? A set of bits or flags or whatnot. And in experience from other large-scale deployments of these kinds of sort of behavioral requirements, over time, it tends to be very, very hard for relying parties to process like large catalogs of values. I would refer you to NIST's work on this in 863, where they've gone back and forth between requiring simple levels of assurance, the classical 1 through 4 level of assurance, to things that have a little bit more parameter space in them, and this vectors of trust stuff that they have been using for the last 2 years. So even though it may be very attractive to reference the WebAuth format here as in a registry, I would take a little bit more look at what's been used in the digital identity industry for well, I want to say decades here, but almost, well, it's more than a decade in this space. And sort of think about how to do this. These are like non-trivial things. Although I agree that if you want to do a catalog of bits, WebAuth is probably as good a starting point as any.
Well, a couple points on this. One, the key attestation formats that I have in mind aren't that old, right? They're not decades old. They're, half a dozen years old or so.
I know. And
Second,
that's my point.
well, I mean, I don't get to tell someone what attestation format to use. I have to consume it as a relying party, right? So, and that's all this is doing is saying these different products, they all have different attestation formats. I'd like a way for my CA to get a hold of them. So this is really just a bucket to carry something from point A to point B. I'm personally not wed to WebAuthn. I don't care if we were to go with just OIDs. That's what I did before in a proprietary implementation. But if Acme is going to do WebAuthn, it just makes sense to me that we make it easier and use the same format for these other protocols.
I agree. I'm just saying maybe not limit yourselves to that particular format, because there will be other reasons to process attestation that will have very, very different formats.
Well, perhaps if you're around, give a listen tomorrow. And I would like, and it's not imperative, but I would like if these two specs were at the end of the day harmonized. So, and I think that one's going to be WebAuthn. So, but this is all good stuff for the.
Yeah, I mean, absolutely. I think one of them will certainly be WebAuthn, right? I don't think it will be the only one. I think that's Stefan's point.
Oh, you're saying why define just an OID for WebAuthn and instead define another bucket type to carry this stuff?
Or maybe something that can encompass WebAuthn and other things. In some situations, it is OIDs, right? In other situations, it's going to be something like an LOA or a vector of trust thing, right? In other situations, it's just going to be like, hey, it's a bit. I'm a qualified certificate. My key has been generated using a QC capable device, right? So it's a range of things. And I agree with you. Relying parties are never going to dictate this, but yeah, it's going to be more complex than just the WebAuthn, even though it will be one.
If you two have something that's concrete that exists in mind, if you could send a pointer to it so that I don't grope around and not find the right thing, that would be helpful.
I'll give you, I mean, Stefan, I'll find you offline, right? But Stefan gave you one, right? And there are multiple of these sort of ways to specify some sort of property of the thing generating the private key or the authentication context.
He gave me some terms with which I could search, but not a specific reference of what does this already. That's what I'm asking for.
Yeah, well, the qualified certificates is one thing, and you can search for that. And the vectors of trust is another. That's another way of specifying sort of assurance for authentication context. And the NIST 800-63 is another one, right? These look very, very different, right? WebAuthn attestation was, I think, an attempt to build something quite simple, but you can go back to even to Kerberos days, and you will find people have been trying to specify sort of the quality of the authentication context. Was a Kerberos Pkix was it done using a hardware context or not, right? That it's been tried, right? And specifying that kind of policy is everybody has their own idea. The WebAuthn people have their specific idea on how to do this. It's just not the only.
There's nothing in this draft that would prevent another draft from referencing such things. I mean, all of this stuff already exists, right? And picking winners and losers, I don't know. We can take that on the list. That's fine. I think I get what you're after.
Yeah, I'm arguing against trying to pick winners.
Michael?
So, Michael Richardson here. So I read the draft, and I think I asked on the list why it was what was the RATS connection at one point. And having listened to the presentation now, I have a much better idea that it's a cross type of thing. And I guess I want to know is, does Lamps want to fight for this, rats for this draft, or does neither want it, or, because it kind of,
Well, this
it kind of seems to go a little bit, you know, Lamps is for the syntax and rats is for the semantics. I don't know.
so right now there are two drafts that I've talked about this week. The one in rats
Yep.
was for defining a structure for distributing trust anchors, which could
Yeah,
be
I
used
know
in this
that.
context, right?
Oh, yes,
And
right.
then
Okay.
here, there's no rats in this draft. You know, this isn't
Right.
using eats.
No, I know that. That wasn't the question, but you're still talking about attestations through the type of key that was created, right? And so the fact that we're creating it, putting something a certificate is what yanks it into this working group. The fact that we're talking about some quality about the private key, okay, and who created it and how and under what circumstances is what yanks it back in the other direction. In my mind.
Except that Carl's already pointing to attestation formats that are already defined.
Already defined. Okay, so I just wanted to ask that higher level question here because we, you know, we've got it.
If you need to define a new one, I agree with you. It probably goes
Yeah.
there.
Okay.
Actually, if you were to define one for eats, I would think that you would define a WebAuthn statement format that would wrap the eat. And I mean, really, at the end of the day, all we're using WebAuthn for is format agility. That's it. And the reason that's being used is because there are some large vendors that emit this already.
Stefan, go ahead.
Does it work now? No. Yeah. So I
Yeah.
just want to make you aware that I provided a link in the Jabber chat to the Etsy work.
Okay, thanks.
Okay. Thank you, Carl.
Ready.
I think it's Sean going to talk about.
So should
Kyber
we do a
certificates.
whole who read it? Can we adopt it? Like that was kind of the point, right? So I don't know if we want to.
Oh, thank you. Is there anyone, stay there, you're next, or come up here. You're next. Does anyone object to this group adopting this document, or does it need further work before we have asked that question? No one's thinking it shouldn't be. Don't see anyone saying anything online.
One support online.
Yeah. Okay, so we'll take it to the mail list. And
Yeah, for all those new people that haven't come to the Ietf a lot, that's what you want is you want to ask at the end, like, what are we doing with it? Because otherwise you leave in this kind of, I don't know what the hell's going on state. And that's not cool. Sometimes you get shot down in flames and sometimes you don't. So that's how it goes. So, hey, this is another one slide presentation. This is the draft that we talked about last time, which is an individual submission still. It's about PQ chem certs. It was going to specify, it's going to be the one that ruled them all, right? It was going to, how are you going to put these chems public keys and certificates, and what are we going to do? And we're going to have this long list of choices, and then NIST picked one. So next. Yes. No, there's a terminology draft that this woman back here is going to write for us. It's going to explain exactly that. So I'm going to leave that one alone. So again, originally we were going to like Howard. Yeah, exactly. Because I'm not a cryptographer, so I'm just throwing it out there, right? Again, this draft was going to like specify them all, and they just picked one. So hey, that's nice. This draft is going to be really short. Here's we're gonna link it down and make it just be one. It's going to specify what the public key is. We are not specifying the OID. We're going to take it from NIST, whatever that is. We're going to say no parameters. You're going to have an OID, and then they've got three options for like low, medium, high, or whatever they're going to call it, or 128, 224, and 256, or whatever it is. We're going to take those names. We're going to go with it, and that's it. But it's the encoding of the algorithm identifier where it's like an OID and parameters. We are not talking about parameters. No parameters. I don't know how many OIDs it's going to be. I think it's, so when I talk with Panos,
Algorithm plus parameters equals 108.
when I talk with Panos, I hope there was only going to be like use and like paranoid, and then we can just ignore the alien level, security. But I don't know what's going to happen. And again, whatever they specify, we're going to do it. The problem is that people will just like go for the super high level, and no, you don't really need that stuff at this point. So we'll do whatever they specify. There'll be a number of OIDs. We won't specify any parameters. Now, a lot of this is like super back history, right, to like 1997 when people screwed up their implementations and required parameters. We're trying to just drop that baggage. So it's like, just don't encode the damn things. So it's greenfield. We're hoping we can get away with that. And then, of course, you got to specify what the key usages are. Well, it's a chem. Pretty straightforward what the choices are going to be, right? So there shouldn't be any real kind of argument about this. And then we have some security considerations. The one part we will have a discussion, I guess, is the private key part, which I think somebody's talking about later. Well, I'm the first PQ one. Everybody gets in line. I'm fresh meat. All right, go ahead.
Yeah, so John, this seems very connected to the next presentation about signatures, but a little bit different. But that presentation said NIST will do this for us. No, you say NIST will do this, and then we will take whatever NIST, the OIDs NIST specify. The other presentation also have a lot of discussion. What does the OID mean? Do we have one and then encode everything in the public key value, like with LMS and RSA, or do we have several OIDs for different security levels?
I think there'll be an OID per security level, and
Yeah.
that's going to be the only parameters. Pick the right OID.
Yeah.
And that's it. Otherwise, we are going to be in like a world of hurt.
Who is going to decide that? Are we going to take what NIST decides, or does NIST want our input on this?
Oh, I think both. But at the end of the day, I think that they've decided the way they came out with the signature stuff. They kind of like picked 3 levels essentially, right? Whether it's 2 or 4 or 3, whatever levels are. We're just gonna, if it's 3, we're just gonna go with those and go with the flow. We're not trying to usurp NIST's. Like let's go write a special publication or FIPS or whatever. That's clearly not the intention. If this draft is long, it's because the key sizes are huge and the examples that I would like to include in the appendix make it longer, and that's it.
We're going to need a new wire format for that.
As the broken record and what's in the charter says we take what's from NIST and not reinvent.
Yeah. So this is definitely again, this is like this, and then the next, the lithium signature stuff. Like we're not trying to do more than we really should, because it's not really, I mean, my personal opinion, it's not our place.
Like Ounsworth, Sphinx aside, we're talking about, like 3 to 5 parameteroids, not, dozens. The comment that I got up to make is I will pick at you about key usage not being straightforward. Just for the record, like chems are a different interface. So they're not a key trans and they're not a key agree. They're something new. We don't want to make a new EKU or KU because gross. Probably, key trans or key agree, both are wrong. I think as long as we all pick one consistently, it's okay. But just don't gloss over that. There is.
So I did want to make the point that you and I and the other authors of your draft have talked, and we want to be in complete agreement so that there's not going to be a fight over like what's the bit. And I think we decided on key trans and not key agreement, and we were kind of like, well, we got to pick one. So yeah, whatever it was we agreed to that's in the draft, I think, is what we're going to do, because we don't want to set up this fight where, the quote unquote composite one, whatever that means, because we're going to get that terminology defined later. We're just going to go with the flow.
Paula, there's just a little trivia. If you have to name things anywhere, like in the IANA registry or having a shorthand, please don't name anything with a dash in there or a space, because there are still some dinosaurs that code in C, and we would really like to map the names one-on-one, and so at least use underscores.
Ah, interesting. Okay, well that'll be nice input to NIST, but yeah, cool. We won't bother with the underscores or the dashes.
Underscore is not printable string.
We'll just skip it and just put the number, the size of the security strengths right after it.
Yeah. Let the C programmers translate dashed underscore, but it worked in OpenSSL, so it works everywhere. Aha! Yeah. Do you actually really need multiple OIDs, or can you just determine what the key is from the length that's encoded in the cert?
No.
I think people like, as you can tell by the groans, I think
Yeah, I
people
know,
like the
but-
explicit, like, here's what the strength value is, the strength is. So that's
We-
only why, that's why we
Yeah,
would do
but
it.
We don't know if there will be multiple parameter sets. We hope they're not, but we don't know that there never will be.
Okay.
And so, so I can't remember if I have another slide or not. I don't think I do. Do I? I hope not.
We didn't do the question yet.
Oh, okay, cool. That would be the next slide. Again, remember, people who've never been here before, ask for adoption. So that would be it. So
Does anyone think we should not adopt this document, or should have a call to adopt this document? I'm not seeing anyone opposed. Is there anyone in chat? No. Okay. So, don't forget my makeup.
Mike Ounsworth, so I'll make an omnibus comment for I think all the PQ stuff, which is, could we like adopt it, start getting the administrative work, the text editing, the sort of general design out of the way, and then like as a group just sort of pause them and wait for NIST, and that way we can synchronize across working groups.
That's exactly what we're doing.
yeah, exactly correct, right? We're not trying to get out in front of our skis to like fail miserably right here. It's like, if we specify some stuff, I'm going to put TBDs in the OID in the play. I'm not trying to squat on anything. Like, we're just, if people want to experiment, they can do what they want. We just won't put the numbers in there so that we're not, because the reason why we want to do that is because later we don't want somebody to be like, no, we're not going to change our implementation, because that's happened in the past and we don't want to play that game anymore.
Yep. And also, to be clear, I mean, this is NIST timeline right here. We've got a whole bunch of drafts. We want to make sure that we get them all done as close to the left side of that timeline as possible. Otherwise, we'll fall off the right side. So, we'd rather hurry up and wait than miss the deadline.
Is Jake here? Ah, there he is. Thank you.
I'm just waiting for control of the slides. There we go. All right.
Pass slide control to you.
Thank you very much. Can you guys hear me okay?
Yep.
Wonderful. Yeah, so I guess for those who don't know me, Jake Massimo, I am at AWS. I did a PhD in cryptography under Kenny Patterson, ETH. So yeah, today I'm going to talk about similar draft as the one previous, algorithms and identifiers for X509. This is the signature version of the algorithms rather than the chems. Okay, I'll just go through the slide.
You should see some buttons at the bottom. Yeah.
Got it. So a little bit of motivation. So what is this about? So yeah, as I said before, the inclusion of the algorithms selected by NIST's PQC project into X509. Right now, the draft is focusing on dilithium, as NIST has stated it as the primary algorithm to be implemented. And of course, it has a reasonable, well-balanced performance throughout. We're aiming here at the description of the pure certificates, so we're not focusing on the hybrid or non-composite, I guess actually composite certificates. But of course, this draft may come in use for the hybrid work as well. So you can kind of think of this as an RFC 3279 for NIST's signature algorithms, and the ID provides the conventions and the syntax for putting the algorithm identifiers and parameters into the certificates. Why now? Just a little bit more motivation. So we are seeing some industry interest scoping out certificates with PQ resistance. These are kind of applicable in the long-term root of trusts. So things are embedded within devices or things that are difficult to reissue. We're starting to get some like custom questions and some like examples from automotive industry, heavy machinery, and IoT devices that may sit on a shelf for a long time before they're ever switched on, and then look to update. Of course, NIST has announced the algorithms for adoption, dilithium, Sphinx, and Falcon. This will take some time, but yeah, it's nice to kick off this process now that we have some algorithms selected. And as I've heard mentioned previously, it kind of aligns with the Lamps Charter to adopt a draft for PQC signatures in PKIX certificates. As was, I think, literally just mentioned, with the TLS 1.3 draft, our intention is for this to be ratified after 2024, once NIST is fully finished specifying and describing the algorithms and standardizing the algorithms. Just clicking the slide. Yeah. So our goals and our non-goals, we kind of already focused over, or gone over this before. So we will. Our goals are to define the data structures for the use of dilithium signatures in X509. We want a clean and concise specification. So yeah, no parameters. We will just have them hard coded in the OIDs. And our non-goals are, we won't be trying to overthrow NIST and say which algorithms to use. We'll be going with NIST's selection and with NIST's selection of OIDs. So just to finish up, a couple of key discussion points. Obviously, for signatures, there are multiple algorithms that have been selected. So we kind of have this, the one ID to rule them all, or do we separate the each draft or algorithm per draft? Of course, multiple algorithms in a single draft can kind of bloat some security considerations. You could imagine talking about the detailed intricacies of lattices and then also hash functions, and it could be confusing as to which security consideration is talking about which algorithm for people that are less familiar with them. So right now we're kind of thinking one algorithm per draft, and another question is which security levels should we include? All of them, a selection of them. Again, we'll be looking to NIST to see what they kind of put out there first, and then being sensible about our choices. We'd also love to hear your feedback. I have introduced the draft on the mailing list, and there's been some discussion on there already about bit strings versus octet strings and things like this. But yeah, we'd love to hear from your feedback, and I guess I have to make the call to add this as a working group item. So thank you very much for listening.
Yeah, hi, it's John Gray from Entrust. Yeah, I think I'm the one that probably made those comments on the bit strings and on the draft, but yeah, I very much support this. I think I was saying on the mailing list, we have already done integrations with customers, and I've already had to change my OIDs 3 times. Obviously, we know that they're going to change, but it would be great to have, a final set that we can use, especially now that NIST has announced. So the sooner we can get those, that just less work for us and better integrations with the different partners that are actually looking to do this. And I mean, we've been doing this for the past couple of years already, so there's definitely, a lot of people interested in this. So thank you.
Yeah, thank you for your feedback as well.
John Mattsson, obviously this is needed work. We need to integrate everything NIST standard. I think for lamps, probably we should do everything that NIST decides to standardize. I think it's hard to know what will be used in the future. Coming back to this OID, it was only 2 years ago that lamps standardizes LMS and went for one OID for all security levels. Now, are we already agreeing that that was a bad choice, or is there any differences between the algorithm that motivates? Now everybody seems to say that we should have one OID per security level. I don't have any strong opinions.
So let me answer that. The difference was the way the algorithm spec was written. The algorithm spec used the RPC encoding of the parameters into the key itself. So you only needed one because the key embedded all the parameters. And so if NIST were to take that approach, then we would only need one. But it seems, based on the way the algorithm specs that they asked for in the competition are not that way. So that would be a big change to the way they're specifying it. And that's why.
Okay, yeah, thanks.
Ori Steele, Transmute. Apologies for not queuing, technical difficulties. I appreciate all of the comments, so I appreciate all of the comments and support this proposal, working on the cozy and hosey representations to mirror what you're all working on here, and I'm looking forward to collaborating, keeping everything in sync.
Thank you. Okay, so this gets us to is this the right approach? It seems that we have some choices on this slide that I think need a little fleshed out. Do we want one PQ signature draft that has all three of the finalists in it, or winners in it? Or do we want one draft per algorithm? I think it's really important in order to know how to structure the call for adoption. Take a poll. Okay, we can do that.
Get in the queue here if I press the button here. So hi, this is Sean Turner. I used to be in the camp for like one draft to rule them all. And I've kind of been swayed over to the other side where it's like, just have one draft per algorithm, because at the end of the day, drafts are cheap. These keys are big, literally. So let's just keep them separate. And I think implementers that really care don't want to wade through all the other crap, right? So if they're picking one, they just want to go with one. And again, it's okay to, we're not saying like, this is the one, this is the one we're starting with. If we're going to do the other two, great, we'll do those two. So I kind of like the idea of keeping one, and it does kind of like, I'm not the cryptographer where, Jake is, and he's like, well, I want to write 30 pages of security considerations about this particular thing. Better to just keep it all together, because it's like, then you've got to, I don't know, I think it's just going to be easier for people, easier. Very smart people read these drafts and implement them, but at the end of the day, I think it'll be conceptually a little easier to have them separate.
Yeah, sorry, I had technical difficulties with the queue. I was just going to say NIST has called for around 4 for signatures as well. So if you put all 3 of them in one, then there's going to be, another one that comes out, and then you'll have to do a separate draft anyway. So you might as well just keep them separate, I think.
Or Steele from Transmute agree in separating them in the cozy and hosey drafts that we've been developing. We have them all together because it's easy at the beginning that way, but I think for a number of reasons that have been mentioned, all of which I agree, it would be good to split them up, particularly because of the call for additional algorithms from NIST.
Roman.
Hi, Roman. I just wanted to be, I wanted to be last. So personal opinion, I think we should split them into separate drafts. ED hat on, I'll support what the consensus is.
Okay, so I started a poll. Should we put each signature algorithm in its own document? I will observe that if NIST publishes them at the same time, we don't care. If this staggers publication, this aligns. Okay, 41 to 1. If the one person, it's pretty. If that one person would like to speak and try and change the other's minds, you're welcome.
Tell us your opinion. Yes.
Okay.
Only had 11.
So, does anyone object to doing a call for adoption for the dilithium signature, which is the one we have a draft for? Okay, thank you. Michael. Did I mess up? Hold on. I didn't get slides.
Okay, Mike Ounsworth. Let's talk about the composite stuff. Next slide. So I'll acknowledge first, there's a lot of, I mean, there's been discussions going for a long time about whether composite or non-composite, like if any of the hybrid stuff is like fundamentally actually useful, or if we're just spinning, trying to develop this stuff. And I acknowledge that's a good debate and there's good arguments, and NSA and NCSC have made their points clear and have good solid arguments. And I'm not necessarily, trying to push that composite is the way. I do think though there's probably, there exists a case in which it's useful, and therefore I think there exists reason to standardize it. And if people are going to do it anyway, for even if it's for ill-devised purposes, I think giving a standardized way to do it that's been CFRG reviewed is probably, generally good for humanity. So I'm not up here trying to argue that composite is the one and only way, but I am up here arguing that I think if people are going to do it, we should standardize it. And also it's easy and we can do it independently from the algorithm definitions because it's totally algorithm agnostic. So like, why not? Is sort of why I'm up here. So this slide deck is basically a call for adoption. I think keys and SIGs are ready for adoption. So Sean had no slides on adoption. I have like 6 slides on why I think adoption is appropriate. And then I've got a bit at the bottom about chems. We have a composite chem draft up. So let's go. So here's the status of the composite drafts. Keys is an 02, and I think it's mature and ready for adoption. Signatures is an 07. I think it's ready for adoption. We've done a lot of sort of shifting stuff back and forth between the keys and the SIGs draft. I think that's all sort of stabilized now. The one thing that's missing that we like had in and actively removed is the and, or, K of n, any, like all that sort of policy stuff. Once we started having or and any as distinct modes, it got stupid and we just took it out. So I think that needs to go back in. Like our co-author dtrust in particular is like already deploying those sorts of modes. So we need a way to specify it that's standardized. I think it belongs in the SIGs draft. Probably it belongs as part of the signature algorithm, not as part of the public key. So that needs to go back in. So these aren't final, but otherwise I think they're pretty mature. And as you'll see in a few slides, we've got starting to have lots of running code, which is a sort of a checkpoint in itself. And then finally, there's composite chems. So we just got composite chems 00 up. If you'll remember about a year ago, we put a composite encryption draft in front of Lamps, and that was really just to sort of garner feedback, and we got a lot. And we proposed in that draft a number of different ways of doing composite. And by encryption, I mean like CMS encryption, where you're trying to encrypt for a recipient with multiple public keys on different algorithms in a way that the recipient will have to use all their keys to unlock the content. So we put forward a bunch of different proposals. I think we've settled on wrapping it all up inside a chem. So you can have an RSA key trans and an X25519 and a Kyber, and you roll them all up together. And on the outside, it looks like a single chem algorithm and will fit anywhere that a chem algorithm fits, is the method we ended up settling on. That's brand new. I think that draft is currently more lines of EndNote than lines of text. So yeah, please feedback. Okay, next. Rough consensus. We're gathering snowball of authors, which is great. We're starting to gather a fair number of positive reviews, which is great. So I think we're clearing the rough consensus bar. Next. I think we're also starting to clear the running code bar. Entrust obviously has, we have this semi-commercially. Bouncy Castle recently, we just did full integration tests against Bouncy Castle. So that's like full support of composite. We are currently working on an OQS OpenSSL implementation. I think we'll have that complete by 115. And then our co-authors obviously have their own proprietary, which we're sort of in various stages of integration testing against. So I think we're also clearing the running code bar here. DKG.
Hi, Daniel Kahn-Gilmore. So thanks for doing this work. It's obviously something that people want, and we want to put it forward. And I just wanted to try to clarify. I heard a lot of pushback in this room earlier about parameters, right? We don't want to have parameters. We don't want to have, too many fiddly bits. We want something specific. This appears to be, it's not using parameters, but it is allowing a wide range of choices, right? Because it's abstract enough that you can composite arbitrary things together.
Yes and no, depending on which section you're reading.
Okay. So I guess I just wanted to highlight that this seems like a tension here. We're going to run into this in the OpenPGP working group as well when OpenPGP gets around to doing this. And I wanted to try to understand your thinking about, or the group's thinking about why we want as much flexibility as there is here and what kind of constraints on flexibility you're willing to tolerate.
Yeah, so good question. So we've written the draft just trying to provide tools. Like anywhere people have asked for a tool, sure, we can, try and provide it. So the draft, at one point we had like generic composite and explicit composite as two separate drafts, and we've now merged them. So you can now with the same wire format say like have an OID that says I am a generic composite public key, and you'll have to look inside me to see what I am. Or you can have an OID that says I am an X25519 Kyber key. And that's going to be a bit of an OID explosion because you'll need to roll all the pairwise parameters in. But we also provide a structure for minting those explicit combinations where the OID will tell you what's going to be in it.
So I guess I was trying to point out that all of these parameters and all this flexibility and all this toolkit is appealing to those of us who like fancy tools. But when we're talking about interop on the actual network, what we need is clear guidance and constraints, right? If you pave a big parking lot, people will crash. But if you give them rails, they'll ride in the direction that you want them to ride. And it sounds to me like this is paving a big parking lot, and there's going to be some crashes.
Hey, this is Sean Turner. I just want to say that one of the reasons why we went for the don't do the whole composite thing was a little bit of that. And you're right, because there are rails, but people can like put 3 wheels on it and like do all kinds of fun things. And one of the reasons why we decided to go with less, right, is that
now you're arguing the analogy.
Well, yeah, so like, I'm not trying to say good or bad, whatever, but like at the end of the day, when NIST did elliptic curve, we had too many choices, and people were like, "What are we going to do?" And oh, look, we've got this name curve thing, and we can do this crazy pants stuff. And so we did the 5480 draft. RFC ended up as a Tiger team. And I remember we got on the call and the guy from Microsoft, whose name's escaping now, Kelvin, was just like, stop with the choices. We don't want to do all this. And it was like, let's just pick an OID. Well, great. Then all this crazy pants ASN1 stuff that we would have to specify just fell away. I don't know, that helped. I think IPR was actually the bigger problem. But at the end of the day, that was one of the things where it was like, there's too many. And so that's why, from my perspective, when we're doing this, it's like, let's just do less, because maybe that is. But if it's a commercial need, I don't know. Because I mean, Pkix doesn't have a really good track record, or the PKI world, of picking a clear winner. There's like 6 enrollment protocols, right? If you're running an enterprise, it sucks, right? Because you got to support every one of those friggin' things, and it is what it is, right? So I don't know. That's just some background for thoughts for future when you go to OpenPGP and be like, what do we want to do?
So I was putting on my hat as like editor of this draft. If that's what the working group wants to do, we want to like use the machinery we have here, but then just say, thou shalt these 2 algorithms. I'm fine if it turns into that. That's a totally reasonable direction for this. Okay, next. So on the topic of running code, my coworker John Gray and I are going to volunteer to show up at the 115 hackathon with the Entrust implementation, the Bouncy Castle implementation, the hopefully by then OQS implementation. And that's that would be, I guess, like signatures and chems if that happens, as well as composite. Like if you want to come and test your PQ X509, CRL, SMIME, whatever, we're gonna volunteer to be at the hackathon to come test against. I think we're sort of ready for that. Next
question about your plans. Are you Michael Richardson? Are you going to run some enrollment protocols because we have so many of them?
Does that want a response?
Yeah. No, I'm serious. I was thinking about this and go, well, there's no point in me bringing my OpenSSL implementation of a CA that does something because you already have one. But then it occurred to me, but I have clients that would want to talk to it, because I would now, of course, like to sign a CSR with a PQ algorithm, right, and send it to you and get something. So that's why I'm seriously actually asking that question. Is that within your thinking at the hackathon?
I mean,
so let's use some mail list bandwidth.
Yes.
Deciding what people want, then show up and test it.
Yeah, I was just going to say, whatever you want, we can probably do. And we can already do CSRs and sign them with this stuff and all that cool stuff. So let us know on the mail list.
Okay, next. This slide, I don't know that I necessarily needed it, but it's sort of a plug. I personally don't view the composite and non-composite as like competing. In fact, I think there's a lot of good uses for both that are independent, like the negotiated TLS type stuff. Non-composite probably makes a lot more sense, but the totally offline, code signing, whatever, maybe the composite does make a lot more sense. Like I think there's, there exists at least one strong argument use case for each. I also want to point out, because I think this gets lost a bit, that it's totally possible to do both together at the same time. Like you could imagine a non-composite TLS handshake. You show up with two separate certificates from two separate CAs, and one of them happens to be a composite, X509 or X2509 and Kyber together, and you non-composite that with a RSA, or like, you can imagine these getting used together. So I don't know that they're competing, and I don't want to think of them as competing. I think they're both useful. I see a nod in the back, and I think I do want to chat with you. Hi. Next. Just a reminder, we have milestones dated like, in the past that adopting these drafts would satisfy. Next. Yeah, here's Sean's slide. Yeah, are we ready to adopt these?
Hi, Jonathan Hamill. So what concerned me is that you're asking for adoption, but then early on you said that, oh, well, you ripped out the composite or and any, but you may put that back in. And to me, I think that how it is now, where it's simple, it's should be done first, and then separate draft could do the alternatives because they have different security considerations.
Yeah, the modes could,
And
the modes
sorry,
could go in a separate draft. It's fair.
and possibly different IPR, because there is an IPR statement on this draft.
Daniel Gilmore again. I do think that these should be adopted. It seems like that's what we're talking about in this working group, and it's a milestone. So sure, I want to. My understanding from the point earlier about, well, we might want to add back in the or the n of k of n or whatever, and adding that specifically to the signatures worries me a bit, in that if you're saying here's one composite key and it can make two different kinds of signatures, you're now creating a negotiation problem, right? Because someone who's going to be relying on a signature now has to express to the signer which types of signatures that key can produce. And I don't know, in the places where this plans to be used, if we have any clear documentation about what kinds of negotiation might be done.
In the interest of...
Did I understand what you're proposing for making that change? I mean, I guess I'm seconding the earlier comment that said, please, let's not drag that stuff back in. Let's just go with and.
Yeah. So first comment is I'm trying not like I didn't do any technical content in these slides. I'm just trying to keep it focused on adoption, and maybe mailing list is, in the interest of time, better for technicals. Second, yeah, the and versus or. I mean, there are use cases for or. They exist. There's people who they want a flag day now to support composite and start shipping them, and then flag day later to turn the algorithms on. Like there's those sorts of use cases floating around. So like I think there's enough people who want an or, and there's people who want or in sort of all sorts of weird permutations. Like every time I take it out, I get pushback. So I don't know.
Victor Duchovny, Google Public DNS. I'm wondering how this plays into things like, TLSA records, which carry a hash of an SPKI. Does this not become ambiguous in light of the new complexity? If I will know that I trust a particular SPKI, if it can be used in a variety of ways, I guess it's the same question in some ways. What's likely to be happening here?
And that already exists with RSA, right? An RSA key can be used with a number of signing algorithms. Is that fundamentally different here?
If it's the same key, it doesn't really matter which algorithm. I mean, if TLSA records specify TLS, you negotiate the signature algorithms on the wire. It's not a big deal.
Yeah, maybe this is a mailing list topic, probably deeper than I can think of on the spot. But the answer probably is no. There's a canonical encoding for these, and
Look at that, I did it. Okay, so this is Deb Cooley. Sorry, I took my badge off. While I think it's very good that you've got a bunch of people interested in implementing these fancy tools, my question is, who do you envisage as the users of these things? As a person who deals with very large PKIs, I will tell you, I do not see those PKIs using these tools. So my question is, who is the right audience for these things?
yeah, that's a fabulous question that I've been asked every time I get up here, and I still don't have an answer that I can say publicly. I mean, we do have customers who would buy it, but I can't, use them as an example. And no one's really come forward as a co-author from the user base. It's a fair question that I acknowledge.
So my question is, if you're going to call for adoption and spend working group time to work on something that is indeed a fancy tool and very complicated and unlikely, in my opinion, to be implemented correctly on a regular basis, if ever. Question is, are you actually interested in spending working group time on it?
Yeah, I was just going to say that kind of puts a downer on what I was going to say, but well, I was just going to say we're calling for adoption to in regards to one of the previous questions. So, I mean, we expect that there will be some changes, or depending on what happens on the mailing list, like the and or discussion, like Mike said, that's come and gone and come and gone. So, yeah, that's expected. In terms of, I guess maybe to address what Deb was just saying. I mean, I can't divulge customers as well, but I know we have a lot of people interested in using this. I think the extra security that it can provide, especially if you're looking at the transition period where we're not sure we trust these post-quantum algorithms fully yet, but we're not sure if there's a quantum computer. I think that is a very compelling use case for using these. And I think customers with high assurance PKIs would appreciate that. So that's how I see that. So.
Maybe a bit of a completely hand-wavy answer to Deb's question, in that it just opens more permutations. But you could imagine using the SIGs without using the keys. Like you could imagine a multi-certificate operation that wants to carry its multiple signatures in the composite structure. Like an example would be the CMS signed data. We can already carry multiple certs, but maybe you want to really make it clear that this is a composite operation. You want to roll them into a single signature. And so you want the data format to have one signature that points back to multiple certificates. Like there might be uses like that. Not aware of any protocols that want to do that yet, but
If nobody, this is Roy Williams, if nobody's standing up to say, hey, they want to build something cool and far reaching on this, just building it and hoping somebody comes to it, I think is a non-goal. Right? Unless somebody's willing to say, hey, this is what I want to use it for, I think it's just open up a Pandora's box.
Okay. Let's take these separately. Does anyone at this point object to a call for adoption on composite keys?
Well, we have at least one in chat. So, Yuri, if you would like to talk to your reasons for not liking composite, I think it would be a good thing to do at this time.
Okay. So we need to discuss that further on the list. And is there anyone who would speak against a call for adoption on composite SIGs? It's the and/or thing, right?
Sorry, this is Jonathan Hamill again. So just to reiterate my previous comment, if the plan is to significantly change from what it is now, I object to adoption on the draft because I think that needs to be fixed before we do the call for adoption.
Okay, so let's be clear. Does anyone object to a call for composite SIGs with the current and structure? Yeah, so at least one person is against. So we're going to discuss that on the list as well. Okay, thank you.
perfect. And then I have one more slide. I guess technically two more slides. Yeah, so composite chems, assuming this is a thing we want to do. So this draft is complicated cryptographically, and I don't want to spend a lot of time up here other than to say that this has been slow to come out because we had to define a bunch of crypto, which is a terrifying sentence. So the two pieces of crypto we couldn't avoid having to define is transformations from a key trans into a chem and from a key agree into a chem, so we can then treat everything as a chem and combine chems with chems. I think those transformations are sound. We based one of them at least on RSC 5990, RSA chem. The key agree to chem, I think, is also sound, but it's new crypto, so I'm flagging it. And then combiners is like a mess. As soon as you allow RSA key trans, where the attacker could potentially have full control over the shared secret, and then they get concatenated, and you got to worry about one shared secret doing block cipher boundary junk against the other shared secret, then it becomes a mess. There's a fair amount of academic literature out there, and like fresh to 2018, 2019, 2021 about how to do combiners. And you've got some number of shared secrets and some number of ciphertexts, and you want to somehow roll them into one shared secret. And there seems to be a lot of different proposals for how to do that with terrifying complexity. So that's, yeah, that's a bit scary in that it's not clear how to do that. Maybe one way is we restrict ourselves down, like restrict the problem statement down so it's more tractable. Like maybe we just ban key trans and then a lot of this goes away. TLS doesn't have this much problem because they're ephemeral. You don't have to worry about like adaptive attacks because the server's only going to use its key once, but in CMS you do. So I think this is a more difficult problem than what TLS is tackling. And it's, yeah, we need help or direction either in doing the crypto right or in simplifying the problem. Thank you.
Okay, so that sounded like a plea for review to me. Complicated crypto stuff here is what I heard. All right. I don't know who's presenting, Ale, Rebecca, or Mike. Okay.
Rebecca Guthrie. I'm one of the authors of this draft.
Wait a minute, I can't find the slides. I know I uploaded them. Why aren't they in the list?
I sent them this morning.
I uploaded them, but they're not in the list to share. Why? Manage slides. Oh, there they are. I'm confused. Close. Sorry about that.
No worries. Okay, so I'm just going to give a hopefully brief update on the changes we've made since the previous version of this draft. Next slide. So we uploaded the first version in March. We presented on it at the Lamps interim in April, and we uploaded a new version in June based on the comments we received at the interim and on the mailing list. So some general changes. We changed the title of the document, and we added a section which just gives an overview of the intended use case for this document. Specifically, this is if you're using a certificate with a traditional algorithm and you want to transition to using a post-quantum certificate, possibly in conjunction with the traditional certificate. Last, we narrowed the scope of the document. So instead of using this mechanism for an arbitrary number of certificates, we're just focusing on the two certificate case, where you submit a CSR that references only one already existing certificate. Next slide. And so this is probably where we got most feedback, and I think we made a significant number of changes here. So we changed the name of the attribute, and we added a couple values in as well. So we added request time, which is binary time specified in RFC 6019, and this is to ensure freshness of the attribute. We added in location info, which is just access description from 5280. And this just lets you point to the location of the already issued certificate. Let's see. We kept one of our fields the same, and this is just the issuer and serial number field. And then last, we changed the signature. So originally the signature was just over that issuer and serial number. And so now what we're doing is concatenating that value with the request time and then signing. Next slide. We also made a minor, well, not so minor, just one change to the extension. And so instead of including just the cert ID, which is the issue and serial number, we're hashing over the entire certificate. And so when I say entire certificate, I mean the already issued certificate that we're referencing, right, that we want to show as related. And I think that's about it. I didn't include a slide about questions related to adoption, but I'm happy to answer any.
Any questions?
Sorry, I didn't join the queue. Is the request time just a nonce, or is it really expected to somehow line up with the clock?
So this is an already defined type from RFC 6019, which is just binary time. We didn't put any normative statements about how in sync this has to be with exactly, when the CSR is submitted. But the idea is that this will prevent reuse of the signature value specifically. And so this is based on a comment we received in the mail list to include a variable value in the signature.
Okay, I guess the question we've been asking all day. Does anyone have any objections to adopting this document? Okay.
So there's a request that chairs add this document to the related document list.
All right. I'm not seeing any objections, so we'll have a call for adoption on the mail list.
Thanks.
Mike Osborne.
Can I just check that you're able to hear me?
Yes, we hear you.
Perfect. Hi, everybody. Apologies that I can't be there in person with you. My name is Mike Osborne. I work for IBM Research in Switzerland and responsible for the team that actually co-authored 3 of the NIST selected algorithms. This is a joint work with a couple of other industry vendors that have been looking in this topic for a while, with maybe the altruistic thought about let's look a little bit about some of the learnings from past episodes in crypto. Realize that I think one of the things to realize, I think it's very in terms of simplification, in terms of hoping that there will be just 2, 3 OIDs for these things, it's a nice starting point, but these algorithms never end up like that. And depending how you start is going to influence how you end up. So the aim of this document really is a set of learnings on how to serialize and identify keys in the sense of both wire formats, identification, the need to compress certain things with the aim that would help, let's say, provide some upfront understanding about where things could evolve down the road. If we can go to the first slide, please. So this is the second iteration of the document.
Mike, you have control over the slides.
Oh, apologies, I'm a newbie here in terms of how to. I see now. Yeah. Okay, that's my learning for today. Never too old to learn. Yeah. So we actually issued a document with all of the NIST finalists earlier in the year. Obviously, there was some feedback in terms of guidance around OIDs. I'll come to OIDs in a little bit. There's this concept about actually aligning with NIST. I mean, actually, my team is one of the teams negotiating and with NIST on how the OIDs will look like and be defined. Some feedback on ASM1 syntax and things like this, but and some revisions around feedback on some of the encoding. So this is really just to step back and say this document is really about, look, that these are, you need to encode private keys, you need to encode public keys. Let's look at how we can sort of like define these such that they can be let's say the learnings can be adopted then by all of the other things that happen in all of the other RFCs. So we have a draft update. You've probably seen the next chart, which is, okay, since that draft update, NIST has made their selections. I can jump over that because you know the selections. But essentially, there's work underway now to update the document in terms of removing all the NIST finalist algorithms. I picked up on the discussion about one document per algorithm versus multiple, something that we can also look at. But essentially, we're restructuring the document according to the NIST decision. Adding the Sphinx algorithm because that was an alternative. Now it's to be standardized. There was a set of discussion around. This is a very hot discussion around among some of us on the what's on the enterprise side in terms of the ASM1 syntax. I mean, it goes into things like partially populated keys. So one of the learnings that we as an organization have had is that, yes, you can start off all nice with, you have the full keys and everything, but at some point then actually these really do not fit in some existing protocols and standards, and we needed to start to look at partially populated keys. So for example, private keys that do not have the public key inside them, or where or keys that can be expanded from a seed, this sort of thing. And so to look at those trade-offs, let's say that discussion, we decided to create a separate document, because there's essentially a debate around where you want the complexity. You will have complexity. It's just a question more of where you want it. Do you want it really in the serialization layer, or do you want it in the layers above? And we thought it is of more value. We create a separate document to sort of debate the pros and cons about this. This all essentially comes into the question, no parameters, or like 1OD is the parameters are implicit, things like this. It's not going to be as easy as that, I can tell you now. We know already that there are going to be different forms of dilithium, for example, deterministic, non-deterministic. We know already there's a lot of interest in the underlying symmetric primitives, those that are already accelerated today, those that are not. So we do see that this nice concept of simplicity is just not going to be like that going down. So this is essentially, it's just to help debate decisions around those sort of things. Obviously alignment with NIST, because we're debating with NIST on this topic. There's interesting discussions around hybrid versus composite. We prefer to call these multi-key modes, because there's various reasons, among them IP reasons. So we understand, observe, and think it's great that the other proposals going off in this direction. And it's kind of like to understand. So what this proposal is about is really key centric. So it's really kind of framed around keys, not how these keys are used in signatures or how these keys are used in key exchange protocols and things. But really it's the debate around storing, defining, and attaching keys to the algorithms to support them. So there are some very ongoing debates around these multi-key modes, as we've heard in some of the discussions right now. And then so if we look at, I can give examples of the platform that we have now, so that on IBM's larger platforms, we're already on our second generation of these algorithms. We're already signing things that need to be around a long time. And so then there is the question of migrating, not keys, but actually keys being able to support or migrate between different versions of algorithms. So some debate around, insofar as that's possible, and it has been possible, to look at what it takes then to actually migrate keys between different versions of the algorithm. So as a newbie, I think that's the last slide. So we will update in the next days the draft that we have to represent the NIST selection, as mentioned. And I think I'm asking for this to be adopted as a working item, but then please correct me if I'm using the wrong nomenclature.
So Mike, I'm kind of concerned that the direction that you're taking and the one we decided earlier are at odds, that you have all the finalists in here. Well, you have even more than that, but and we're not sure that NIST is going to release them all at the same time. And so we can't get ahead of NIST. And so the way you've structured it, we could not approve this document till all of the NIST algorithms are published. Whereas if you had one per algorithm, we could release that as they were done.
I think that's fine. I think that's what I picked up. So to actually then to restructure the document, or to actually create 4 documents out of this, I think sounds like a sensible suggestion. Yeah.
Yeah, and so we'll do a call for adopt on each of those.
Oh, okay, that's how it works. Okay.
Okay. Michael's running to the mic.
Michael Richardson. So as I understand, you are doing the private key formats in PKCS 8 for the various pieces. That's right. So I'm wondering when we
Private
do
key
have
formats for PKCS 8.
Yeah, yes. If you want to put them in PKCS 8, this is how you do it, right?
Correct.
So I haven't only learned of your document today, so I haven't read it yet, but I'm thinking that there's maybe a lot of commonality, and so maybe the first document that we approve winds up having more details about things like that. And then the subsequent ones just say, and
I don't
no,
think, I don't
okay.
think
I
that's
just wondered
true.
whether that's a point where we're
No,
needlessly repeating,
they're different.
or is it needful repeating?
No, they're different enough.
They're really enough. Okay, thank you.
Especially if you look at Sphinx and Lithium, right? There's like nothing.
So, hi, this is Sean Turner. I guess there'll be some overlap, and we'll have to do some horse trading to figure out where they're going to go, because the draft that I had actually put the private key format in the draft as well. So there's a little bit of like, well, what are we going to do? Because again, one place for the implementers to go. I'm just trying to figure out what's gonna go on. So, and again, the only other thing I want to say is, that in the not too distant past, the choices didn't help. And so
Indeed.
I understand that some people want to have all the bells and whistles and all the knobs, and that didn't help, broadly speaking. It didn't help adoption. It actually like slowed it down. And then there was IPR and the whole 9 yards. So I appreciate when it's like, hey, we can drop stuff out. That sounds like compressed keys. Is that IPR? I don't know. So we'll see what happens when all the, NIST things fall away.
Good point. Let's have the discussion of whether, when this being broken up, should be put into each of the other documents instead. That'd be a option. Okay. All right. I'm shocked. We only ran 2 minutes over. All right. Thank you. Is that a good thing or a bad thing? Now what room am I supposed to?